Hello friends, I'm Prabhat Sharma and today we'll take a look at OpenObserve. OpenObserve is an observability platform that allows you to capture logs, metrics, traces, all of those three together in a single platform and allows you to visualize them and analyze them using dashboards, send alerts using scheduled and real-time alerts, okay, and enrich, redact, or reduce your incoming data using functions. Also, you can query your logs and parse them during runtime using functions. So uh, let's take a look at certain features of OpenObserve. It's super easy to use either in the cloud mode or self-hosted mode. Uh, if you take a look at, it's an open source project. You can take a look at the GitHub repo here. We built it in Rust for high performance, and the front end is built in Vue, which is super cool framework. We love it. Yeah. And yeah, so it's super easy to use a single binary if you're running it on your own. Uh, okay, use a very low amount of resources. People are running it on Raspberry Pis at this point in time for capturing their logs. Okay. When it comes to storage, the storage cost can be as low as 140 times. It can be actually even higher or lower depending on the entropy of your data. So if you take a look, we did a test here on ingested. We ingested same amount of data at 185 GB of data in Elasticsearch and OpenObserve, and what we found was that OpenObserve was 140 times cheaper to store that particular data, apart from a lot of other benefits. But this is just one of them. Okay, okay, cool. So you could run it for a couple of megabytes on your laptop or on Raspberry Pi to petabytes of data. Okay, if you have huge amount, if you're a big organization, yeah, it can run in a single node mode or in HA mode. Okay, either ways, up to you how you want to run it. We have people running ingesting terabytes of data on a single node. So yeah, that works too for some people. Of course, you don't have high availability when you're running in a single node mode. Okay. It supports storage in S3, GCS, MinIO, and Azure Blob, and anything compatible with the S3 APIs. So that works. Okay. It has a beautiful UI, and we'll take a look at that. Okay. When it comes to querying, you can use SQL. Okay. You don't really have to learn a new query language for this. Almost every log platform that comes up has its own query language. Like Elasticsearch has DSL, Splunk has SPL, New Relic has NRQL, Loki has LogQL. You don't really have to learn one more thing out here. Just use SQL. Most people know SQL, and if you don't know SQL, there is plenty of tutorials and references available. You can actually go ahead and ask it in English in ChatGPT, and it'll generate the SQL for you. Uh, okay. So you could use SQL to query your logs, metrics, and traces. For metrics, you could actually also use PromQL. So that's pretty handy. And PromQL is super powerful when it comes to matrix data, which and you can do things very easily in PromQL. That will take a good amount of time doing it in SQL. So PromQL is kind of almost an industry standard out over there, and you could ingest traces using OpenTelemetry. So the standard SDKs of OpenTelemetry can be used for sending trace data to OpenObserve. Yeah. So some of the features: SQL-based query language, alerting, schedule and real-time alerts, dashboards. Okay, you don't have to have multiple different tools with OpenObserve for your observability stack. You don't need Grafana for dashboards, Elasticsearch for logs, Prometheus or Cortex or Thanos for metrics, Jaeger for tracing. All of those things are bundled in a single place. Okay? Makes life super easy. Object store based data storage, dynamic schema evolution. Don't have to worry about the schema when it is ingesting logs, security, fine grained role based access control. This is still in works for the most part. Okay, the basic role based access control is available, but super fine grained that's in development should be available very soon. Okay, and very advanced GUI. Okay, user defined ingest and query functions. Like I said, think about the data that is incoming. Okay, how many times have you heard your team saying that, hey, We logged users' email IDs or SSN in the logs. Now we got to go ahead and delete them. Okay, how do we delete them? Mm, Anybody's guess. Well, there are 100 different ways of figuring those things out, but those things are not super easy. What if you can actually prevent that from happening in the first place? When data is being ingested, write a function that based on regex or something else. Okay, it will filter out those particular records, redact them, and you're done. So functions, you can actually use them for redacting, enriching. Okay, so if you have an IP address and you want to put a geolocation data, like city or country for that IP address, you can actually do that. Okay, you could reduce the data, you can delete certain fields, those kind of things. We provide support for multiple languages, English being the primary language, supported are German, Spanish, Portuguese, Japanese, and quite around 10 plus languages. And you need more, just let us know. And yeah, here are a couple of blogs on how to stream logs from Kubernetes to OpenObserve using FluentBit. And this is the kind of a launch blog where we wrote about why we are building on OpenObserve. Okay, so yeah, that's it. A quick, we'll take a look at OpenObserve Cloud today. Cool. So we'll do a quick get started. Okay. Just click on get started. You'll be greeted with this login page. You can log in with either Google or your own email ID. We'll be offering more social logins like GitHub, Microsoft, Amazon. Okay. And in some time to come. Okay. So I'll quickly log in here. And I'm logged in. Okay, cool. The first thing that you'll notice is that this is a multi-tenant organization. I have two organizations here. I can create more organizations. That provides a good amount of separation across teams or organizations if you want it that way. You can take a look at the documentation. And I mean, this is a set of features. You can go through these when you have some time. Okay. What we'll be doing today is we will be going through the quick start. Okay, to help you demonstrate a couple of things on how OpenObserve works. So, okay, here we are. What we're going to be following is that OpenObserve Cloud today, and in another video we'll cover the self-hosted installation as well. Yeah. So here, the first step is to go to cloud.openobserve.ai. We're already here, actually, from this link. So we are here, and then first thing is let's take a look at the menus that are available. Okay, you have some languages, you can change your to your favorite language if it is available. If it is not, do let us know, and we can go ahead and add that. We use AI to generate these. For the most part, we should be able to get the language that you're looking for. Yeah. But which also means that these might not be super accurate. So if you find some challenges with the auto-translated ones, do let us know. And probably we may not have expertise, but we could use some help in those areas. Or we'll try to figure out something. Yeah. So we've got logs, metrics, traces, dashboards, functions, streams, organizations, alerts. We'll cover each one of them, but this is our logs UI. It doesn't have any data, but we'll ingest some data and take a look at it. We'll explore something. The first thing to take a look is ingestion. You could ingest logs, metrics, or traces, and curl is primarily just for example here. You could use FileBit, FluentBit, FluentD, or Vector. We generally recommend FluentBit or Vector because those are super fast and super efficient on memory. If you're on AWS and you want to ingest logs from say CloudWatch or VPC Flow logs and a couple of other things, I mean, you can go ahead and do those things right from AWS console. Okay, makes life super easy. And then you have got metrics. You can capture either by Prometheus, Hotel Collector, or Telegraph. Okay, the primary mechanism for ingestion is Prometheus remote write, and traces primarily using OpenTelemetry. So pretty open standard out here. Nothing proprietary. So you should be happy about that. So let's go to quick start. What we'll do is that we'll ingest some data. Okay, let's load some sample data. Okay, so we'll download and unzip some sample data. Okay, let's go to our terminal here. Okay, we don't have anything here. We'll copy paste what we copied from there, and then so we downloaded this particular zip file, and then we unzipped it. Okay, let's open this in Visual Studio Code. So this is the file. If you take a look at the file, this is what it is. It's a standard JSON document. Okay, and this file is actually an array of JSON documents. So these logs are our production logs from many months ago. So yeah, pretty standard real life logs. Now what we'll do is that we'll go ahead and try to ingest them. Okay, let's go to our quick start. What you want to do actually is copy this particular curl command and we'll paste it here. Okay, so let's break it down a little bit. This is my user ID. This is my ingest token. Okay, you can actually receive the token from here. This is the API endpoint. This is the path, and this is the organization. Okay, and this is the stream. Okay, you could change this to a different stream if you want to organize plumbing it from, say, application 1, application 2, you could do that. And unlike Elasticsearch, you don't really have to partition data and streams for on a per day basis. Streams are kind of equivalent to indexes in Elasticsearch. We do not do kind of indexing like Elasticsearch does, but at a high level, more or less, stream maps to kind of index in Elasticsearch. Okay. But you don't have the challenges of Elasticsearch where you have to have a stream or an index on a daily basis to make things faster. Things are a lot more easier here. I mean, we are much efficient on that front. So let's copy. We have already copied this. Let's go to our quick start. It says that replace the URL with what you got from OpenObserve Cloud and append it with this line. So essentially, this particular file name. Okay, I'll delete this last piece. I'll double quotes and that's it. Okay, we'll copy this and let's run this. So, okay, before that, and this is around 8.4 MB file. Okay, so we'll upload this. Uploading 8.4 MB on our internet connection will take me like a couple of seconds, but in general, it is super fast if you're doing it locally. So 3,846 records that we ingested, 0 failed. I think we should be happy about that. No failures, right? Okay, now let's go here. So we're done. Let's go to our logs. Let's quickly refresh this. And you've got default stream. And yes, we can see the logs. Time for claps. Okay. So we've got these logs here. You can either expand it here and see each one of them, or you can click somewhere in the middle. Look at, maybe get a lot more space here. You can move, okay. And you'll see the different kinds of different log lines. You can have a JSON view here as well. You can filter based on, say, container name, include search term. It will appear over here. You could run the query. Okay, so that will work. You could Kubernetes host, the top Kubernetes host, say this one. And say this Kubernetes host, and then say namespace. I want, say, this one. Okay, so let's run this. So we'll get some output. I can add the fields here. Say, let's get rid of this, so I can see the namespace. I can see, say, the Prometheus label. So I don't have a Prometheus label for this. So say pod name. I should have a pod name. Yeah. So I have pod names. Okay. And say host names here. So we see that here. Then you can of course have your log statement. And that is exactly what we want, right? At the end of the day, looking at logs and trying to figure out what went wrong there. So yeah, so that is pretty super easy to use. And under the hood, it's actually SQL. If you see, select start from default, where I mean, all we do is that just hide this. That's a fancy one. You can go back, wrap it up. You can see a syntax guide on how to do things. If you want to search for, okay, some feel like error. Okay, you can search for error. You'll get errors. All the log lines where you have error. So by default, okay. So it's not kind of full text indexing like Elasticsearch, but we do kind of a full text search on the fields that you define. So the way it works is that you go to streams, and if you want to do full text search, you'll have to define those particular fields here, like log, message. Some common fields are pre-selected, so you don't really have to worry about them. But think about it. Container image. You don't really do a full text search on that. You generally know what a container image is. Host. You generally do equals or not equal search. So not doing full text is super expensive in general. This kind of trade-off, it makes your life easier and things more performant if you do it more diligently. Okay, so here we go, and so that's how logs work. Let's quickly take a look at dashboards. In fact, yeah, let's take a look at dashboards. So I had some demo dashboard, but we'll start again here. Say demo 2. Okay, here we are. You can click here add panel or click here plus sign to click a panel. You can have logs, metrics, and traces. I mean, based on anything that you can create a dashboard if you have, and you have, say, for example, let's do this thing on x-axis, Kubernetes host, and say pod names, not pod names, let's say, or say, yeah, so let's do pod names. On y, let's do count and distinct count, and let's apply. Okay, pod names. What do you say? Pod, pod, pod names. Uh, pod names, host. Okay, and we see apply this. So it gets saved. It generated a SQL query automatically. If you want, you can convert this to custom SQL as well. Okay, let's save this. Yeah, here you go. And this is done. You could create one more here. So logs based on say container name and say container name. Okay, x-axis, host y-axis, god name, y-axis, and I will create a table here this time. Okay, so table view. Feel free to play around again and convert custom SQL as well if that's the field you don't like the field names or want to do something custom. So that should work. And yeah, out here. So let's arrange them here and say if this for logs. So, but if you're selecting metrics, you'll actually get PromQL option as well. Okay, we don't have any metrics right now, but PromQL works too. Let's take a look at, let's go back to logs once. Okay, let's remove this and run this. Okay, let's run this query. Okay, and let's remove this. Let's see all the fields. So let's quickly take a look at this particular log line. In EKS, these are EKS logs, logs from applications running in EKS. So almost every log line has this annotations. It doesn't really help me. This particular line, okay, EKS.privilege. Every container has this. What I want to do is get rid of this. This is not helpful. Container hash, I've never used it for logging, but I mean, if you want, you could use it. And Docker ID, I've never used again. So what you can actually do is that let's do del or delete essentially dot. Let's remove this particular one. Okay, and then that's a dot. Dot essentially returns the original data as a record. Let's delete a couple of this container hash, del dot container hash, and what else? The Docker ID. Let's delete that too. Del dot. Yeah, that's it. And let's go ahead and run this. So you get an output. Let's see what do you have here or here. See, you don't have those fields anymore here, right? This is pretty awesome stuff. Okay. While you can be able to do this at the query time, the data has not been deleted or anything. But say you could save this as remove fields. Remove fields. Okay. And it gets saved. And then what you can do is that you can actually apply this function at the ingest time. Okay, so if you go to functions, okay, you have removed. I think I should have. I did not save it for some reason. Okay. Oh yeah, I did not click on save. So okay. So okay, I forgot to hit the save button. So the way essentially it works is that let's take a look here. So we do not lose any data, but it's super easy. Okay. Del dot. Okay. Del dot. What else? Container, not a container image. Hash. Okay. Del dot What else do we want? We want a Docker ID to remove Docker ID as well, right? Here you go. And then remove dot. That's the original stuff. We run this here. Remove function, remove fields, and press enter. Then you've got to click here to save. The function saved successfully. Then you go to functions, and you're here. And what you can do is that you can associate it to a particular stream. So, like for default stream, you can associate a function here, say remove fields, and once you have done this association, for all the incoming data, these fields will automatically be removed. Or in fact, whatever the function does, okay, whatever the function does, it will do. So you can use it to delete, enrich, say like if status 0 and 1, you want to pass them, convert them into success and failure, you could do that. If you have an IP address and you want to use the geolocation data, you want to change the IP address to your city, country kind of stuff, you could do that. Those things are possible. Okay, you could redact certain data like email IDs have gotten in, SSN has gotten in, into the keys have gotten into logs. So you can actually redact all of that at the time when it is incoming. It's in the incoming stream. That is super powerful. Okay, so yeah, that's all for now. Okay, feel free to ping us on Slack. That is where this is where help. Click on this, you'll be taken. Okay, and yeah, that's all. Have a good day.